My name is Brett Anderson. I was invited to talk about the winter of 2011-2012 and why forecasts were not that accurate for this past winter. Also, we're going to talk about what some of the tools we use to come up with these forecasts, what went wrong, and why. And then we're going to also give some clues on the upcoming winter. Sure. When we made up a forecast back in September, October 2011, there were a number of things that we looked at to create the forecast. One of those things was La Niña, which is the unusual cooling of the Pacific waters. We were currently in a weak to moderate La Niña. And so when you factor that in, that typically has a major effect on the weather across Canada and the United States during the wintertime. So that was one factor we had to consider. Second factor, we also had colder than normal sea surface water temperatures off the west coast of Canada. Third, sea surface temperatures across the Great Lakes were running warmer than normal. Arctic oscillation, the North Atlantic oscillation, those basically jet stream patterns across the far north. We had to factor that in. And then analogs, which are basically how we come up with those are as we look at the atmosphere over the past year and we try to look for a match, a historical match, and then we come up with the years that are similar. We grab those years, and that's actual data, actual history, and we try to come up with a forecast for the winter using that. So that's some of the tools we used. Well, there are cycles with La Niña. They typically go for 6 months to a year and a half, actually. So you can use that to make a seasonal forecast. However, when I talked about the North Atlantic oscillation and the Arctic oscillation, those are highly variable during the season. They can change 8, 10 times during the season. So we can't forecast that out in October, but they are very critical to the forecast. There's also another cycle, the Pacific Decadal Oscillation, which is a cycle which can last 25 to 30 years. And that's partially responsible for the cold water off the west coast. And that will have an influence of cooler, perhaps drier conditions across British Columbia. At least that's what we factored in for this current forecast. A usual La Niña winter across North America shows cold weather across Western Canada. Not as more up in the air across Eastern Canada, but after looking at computer modeling, which is again very important when we make these forecasts, everything pointed to an active storm season across the Great Lakes into southern Quebec. And so we figured there would be a little bit more snow than normal this past winter. That did not come to play. When I made my forecast, I did note my confidence was highest out in Western Canada, the least in Eastern Canada. A lot of people do not do that, but I think it's a great thing to use to show people where the strength of the forecast is. Also gives us a little bit of an out too, in case we're wrong. I was least confident in Eastern Canada with the forecast. So the forecast actually ended up being slightly less snowfall, warmer certainly than normal, which was not, we predicted near normal temperatures across Eastern Canada and near to above normal snowfall. So obviously that was wrong. But I could say, oh, my confidence level was not that high. But in Western Canada, where we had the greatest confidence, that's where our forecast was most wrong. Especially in the prairies. It was an incredibly warm winter. And everything pointed out to being a cold winter. Nothing told us this was going to be a warm winter. And anyone who put out a forecast saying it was going to be a warm winter out in the prairies was just guessing, in my opinion, because nothing suggested that. Maybe they just want to be against the grain, because most of the other sources for weather information also went with a cold winter, which that's what we thought too. Especially in seasonal forecasts, the computer is very important because, well, the human can use climatology as a friend. What does a typical winter bring? That's our friend. We know what the climate is in Eastern Canada. We know what the climate is in Western Canada. So we keep that in the back of our mind. The computer looks at the atmosphere and uses different equations, which we can't calculate in our head on an everyday basis. It's impossible. It would take us 10 years to come up with a forecast, but the computers do all that very quickly and make our job a lot easier. But you got to know the biases of these computer models. There's a number of computer models which have a warm bias, some have a cold bias, some have a stormy bias. The Canadian model, for instance, tends to be too weak with storms along the East Coast. Then it gets it right maybe a day before the storm. The American models do a good job in Eastern Canada, but they're not so great in Western Canada. The European model tends to flip and flop a little bit. When you see a computer model flipping and flopping, going from one solution to another, you got to be suspect about it. You look for computer models that are consistently showing an idea. And then if you have a number of computer models agreeing with that, that gives us the most confidence in the forecast. And so we use our information that we know about computer modeling, what their biases are, to help us come up with a forecast. And again, we also know we know how to interpret those models to show what's going to happen. I can tell you what a weather pattern is going to be just by looking at the jet stream across North America without looking at a surface map with fronts, high pressure, low pressure. I can just tell you what I think the overall pattern is going to be just by doing that, and that's our skill that we have as meteorologists. One computer model that we really like to use in terms of long-range forecasting is the European model. It's a very good model, very consistent model, better than what we have in the United States, and also in places such as Korea and Japan. Canada does not have really a forecast model that goes out that far, but the European model is actually the best of the bunch. What we found out to be has the best track record, and that's one of the models we really look at and actually forecast well out in advance. This past winter, the European model is actually the best tool that was closest to the actual outcome of the winter. So we're most comfortable with that model, talking strictly about computer models. Personally, I think you should look at all the different forecasts out there, compare them, and maybe take an average sometimes. Especially during a storm situation, it's never wrong to look at all different forecasts, all the information that you have, and then decide for yourself. Usually, just like we as forecasters don't look at one computer model, we look at several different computer models and come up with kind of an in-between average there. It's always, I think competition is great. Well, computer modeling is usually not great in predicting the microclimates. There are computer models now that are called, basically the resolution is very high, and they're really great for picking out small details within a mile of the weather, because they look at the terrain very closely, the influences of the ocean. So one model is called the MM5. It just, no one knows what the MM5 is, but that's one model that is used to decipher the differences between one mountain, which is 5 kilometers away from another mountain. These global models, such as the European, the Canadian model, they can't pick up those differences. So as forecasters, we need to look at some of these more high-resolution models to do that. One. Two, we need to understand why the weather is different in these areas, and a lot of that's due to terrain, of course, wind currents coming down off the mountains and whatnot, coming in off the ocean. We have microclimates all across the state of California. We do forecasts of California, and there's a big difference in weather. And the microclimates are all over the place. They're a big challenge, but a lot of the forecasting ability from that just comes from experience. It takes years of experience doing forecasts in those areas, and to know where, in a certain weather situation, this place is going to have so much snow, or this other place is not going to have much snow at all. It just takes years of experience. And we have a number of forecasters who been doing forecasting in specific regions for years, and they know this. And that's what we do when we ingest all this data at AccuWeather. We put it together and we make more detailed forecasts for the microclimates, because the computer models themselves just can't do it. It's just our experience, and so we make a better forecast. We'll use what happens this summer to make the winter forecast. So we will look at the overall jet stream pattern, which is common in this summer, and we will come up with a year that had a similar summer, and we'll use that as an analog. Right now we're using, as you said, 2006. That's just one year. We'll come up with more years as we get closer into the fall. The 2006 winter, 2006-2007 winter was actually a very warm winter across central and northern Canada. Not a very ski-friendly winter. But that's not the only year we're going to look at, and there'll be more analog years which we'll come up with based on what goes on this summer, of course. Short-range computer models, they'll tell you how much precipitation is going to fall. They'll tell you how warm it's going to get. But us knowing the weaknesses of that model, we can tweak that. And that's what we do at AccuWeather. We take all these models, put them into our computer system, and then as forecasters, we tweak it every day. We do that 3 times a day. We tweak those, and we come up with our own forecast. Yeah, we obviously see a lot of difference in the forecasts from the competition. For instance, I'll give you an example. Environment Canada, they have their own Canadian forecast model, which they obviously going to favor their government organization. They're going to go with their forecast model more than anything else. They tend to stick with that model, but that model is going to show something different most of the time than an American model or European model. What we do at AccuWeather, we look at all different models and we put them together and come up with a forecast after the forecasters put their input into it. So by using different forecast models, you're always going to come up with something different. And then the skill of the meteorologists. It's hard. I'm not going to say the skill of the meteorologists in Environment Canada is weaker than what we have, but I know what we have is very good. And different meteorologists are going to interpret the weather differently, interpret a computer model differently. So it's almost impossible to have almost the same exact forecasts out there. Though on a day such as today, the sun is out, you would hope most of the forecasts would say sunny. But sometimes that doesn't happen. But a lot of times they're fairly close, so just within a couple degrees, and maybe the wording's a little bit different. But there are times when we have storms, obviously, when one may say snow, the other says rain. That's not uncommon, mostly because one computer model may be different than the other. Forecasters are very dependent on computer modeling for the forecasts. A lot of people don't look at computer models, but they're all there, and they're free. They're free for public use. There's Environment Canada has computer models on their website. AccuWeather, we have a premium professional site, which there's a small monthly fee, but we provide all the computer models, and people who use it as a hobby can look at the computer models and decipher for themselves what they think is going to happen, but it's all right there. And there's also computer models by the National Weather Service, Europe, UK Met, Japan. When I first started forecasting, there was probably just a handful of computer models. Now it seems like there's hundreds, and that's a good thing, but it's also a bad thing because you just can't look at them all, and it gets confusing. It's a different world nowadays, but it's all out there. People can you Google it and you'll find computer models. You can find it. In terms of long-term trends in Canada, the signs aren't that great for the ski industry in terms of temperatures. We've been warming about 3.5 degrees Celsius since 1948. And we've had the normal ups and downs each year, but the overall trend is clearly upward. So that's unmistakable, undeniable. Global warming is happening. Most of the warming is up in northern Canada, less in the south, but it's happening. In terms of snowfall, though, and precipitation, well, there's been a slight increase in precipitation, and snowfall is a little more variable, but just because the planet's warming does not mean there's going to be less snowfall for the folks in eastern Canada, because we're still far enough north where a lot of the storms are still going to be in the form of snow. And actually, if we do continue to warm up, which we are, the storm tracks are going to come a little bit farther north, which in many winters, the storm tracks are too far south for Quebec to bring snow. So a little bit farther north is not such a bad thing. But the temperatures are warming, so in terms of snowmaking capabilities, that may be reduced a little bit because with warmer temperature comes higher humidity. So you might have less days where we could turn on the snow guns. But I think natural snow is not so much of an issue, at least for the next 20 to 30 years. Going any time before that, you only have maybe 1 or 2 tools to use to come up with a forecast. You don't have any model data. No model data really goes out that far. So you're dependent on something like La Niña or El Niño. But in this case, we're in between the two. So you kind of can't use that either. So you're really limited just a couple of small tools to use to make up a forecast. So we kind of shy away from making a forecast that early. The odds of getting it right are very slim. So we make it up in September, October, which is still actually earlier than a forecaster such as me is comfortable with. I'd rather wait till the end of November to make a forecast, but there's a demand out there for our forecasts from home improvement industry, energy customers. They need to plan out 12 to 18 months ahead of time. At least for something like a Home Depot needs to plan their inventory. If it's a warm spring, well, they're going to need a lot more plants. If it's going to be cold, snowy winter, they need more shovels and salt. So that's what they need to plan. And energy customers, obviously, they're gambling with their money, and they need to find out well in advance the futures and stuff like that. So there's a demand out there. It's earlier than we like to make forecasts, but we have to do it. So we start out in October, and it's when we feel most comfortable. And by that time, we have the computer models helping us out with the forecast. And we have a pretty good idea what the current atmospheric conditions may be by the winter time. Okay, clues about the 2012-2013 winter. Well, it's too early, of course, as we were talking about, to make up an actual forecast. But we have some clues. La Niña is over. That's one thing. We're in between La Niña and El Nino. It looks like we're headed towards an El Nino starting late summer, fall. Strength of El Nino is very critical to the forecast. We tend to favor this is going to be a weak El Nino this winter. So we factor that in. We look at other years that had a weak El Nino starting the winter. Right now, a weak El Nino is typically a little bit colder than normal across Ontario and Quebec, but drier than normal, as the storms may actually be a little bit farther south. Across Western Canada, it tends to be a little bit warmer than normal, drier normal in British Columbia. Land Canada tends to be a little bit stormier than normal. So that's one clue we look at for the upcoming winter. Analogs, as I mentioned earlier, 2006 is one year I came up. That was a very warm winter, unfortunately, for much can't. But the warmth was actually shifted farther north. When the warmth is that far north, there's room for cold to come in underneath, and also storms to come in underneath. So I think there's a little bit more hope for snowfall and cold across southern Canada, despite what 2006 brought, which wasn't the greatest ski season as I looked that up. Computer modeling, not quite there yet, so it's a little bit early yet. We also have a low sea ice in the Arctic. There's been studies showing that favors blocking patterns in the far north, which when we have blocking, especially on this side of the pole, tends to bring the cold air farther south. Last winter, the blocking was on the other side of the pole. Didn't help us out too much. We still don't have the science there to predict where the blocking is going to be, but there may be more blocking than usual as we have less sea ice in the north. And that's going to continue to be an issue years on, as long as it's business as usual. The Climate Change Department. And then we have colder water off the west coast. That could have a cooling, drier effect for BC. Great Lakes still looking warmer than normal. So if we get enough cold air masses coming down into Great Lakes, we may see more lake effect snowfall, because the warmer lakes set the stage for more lake effect snowfall as long as it gets cold. So that's some of the clues we're looking at for next winter. We cover the world. We are #1 in terms of overall global forecasts. We cover all over. We have international forecasters, Canadian forecasters, obviously United States forecasters. We have the largest collection of meteorologists anywhere in one building, over 80, with a lot of experience. So, and we're open 24 hours a day. The weather never stops, but we've tested our accuracy against Environment Canada, also the National Weather Service, and we consistently, not all the time of course, but consistently come out on top with our forecasts. So we're very confident in our abilities. We were the first actually company to provide pinpoint ski forecasts for the industry in the eastern United States back in the 1970s. We provide temperature data every hour, winds every hour, snowfall every hour, rates, different levels of the mountain, and we provide those forecasts for dozens of skiers across the eastern United States. Now a lot of that's becoming automated, and a number of the ski areas tend to use find the weather information on iPads or on the computer and whatnot. So times have changed, but we were the leading company in developing those type of forecasts. Yeah, I write a Canadian weather blog, AccuWeather.com. It's kind of hard to find it. You got to click on blogs on the front page, but I'm right there. I write my blog every day, usually in the wintertime when there's a lot more weather to talk about. It gets kind of boring in the summer. But I focus on long-range forecasts. I interpret long-range forecasts, the European specifically. I try to show what that model, which we think is a superior model, is showing in its long-range forecast. That model is not free to the public, so what I do is I kind of draw it myself to kind of give people an idea of what's going on. I'm the only person that does that. But I also talk about snowstorms. I put snowfall accumulation maps on my blog and my own ideas, and especially focus on eastern Canada more than the west, a little bit more. But I cover the entire country, of course. Summertime, again, I write more about long-range forecasting. I also write a global climate change blog, which I try to focus on more the studies that are ongoing about climate change. The planet is warming, but obviously a lot of people don't believe that man has anything to do with that, and unfortunately most of the people that comment on my blog believe that man has nothing to do with it, so I get a lot of flack from that. But all I'm doing is presenting data, so and people can decide for themselves, but I think the data is undeniable, and that's what I do. And I enjoy writing both blogs, but I really enjoy doing the Canadian weather blog. People write in, and I have a lot of good interaction with people through the comment section, and it's been a lot of fun over the past 4 years. Yeah, it's been a pleasure.